In this video, we're going to discuss decision structures and Boolean logic. Basically, this has to do with how we choose between multiple paths based on some decision we have to make. So, the way we do this choice is with the if statement. It is called a control structure, and it's a logical design that controls the order in which a set of statements execute. A sequence structure is just a set of linear statements. A decision structure is specific actions performed only if a condition exists, also known as a selection structure or an if statement. The basic if statement is represented in a flowchart by a diamond, which is a true or false condition that must be tested. The actions can be conditionally executed when the condition is true, but only when. So this is a single alternative decision structure, providing only one alternative. If it's true, do this, otherwise continue on. See, here we come in. If it's cold outside, true, yes, wear a coat, otherwise just keep running and going. The syntax in Python is if condition, we'll talk about what a condition is later, then we have to indent our statements and statement, however many you want. If this condition is true, these will be executed, otherwise they will be skipped. Boolean expressions and relational operators. Boolean expressions is how we determine what that condition is. And they are tested by an if statement to determine if it's true or false. For example, A is greater than B. This is true if A is greater than B, false otherwise. The relational operator is the greater than. It determines whether a specific relationship exists between two values. Greater than or equal to and less than or equal tests more than one relationship. It's enough for one of the relationships to exist for the expression to be true. This is greater than or equal to and less than or equal to, there be at range. Double equals, the equal operator called equals, determines whether the two operators are equal to one another. Don't confuse this with assignment. The not equal operator determines whether the two operands are not equal. So here's some examples. X is greater than Y means is X greater than Y. X is less than Y, so on and so forth. X equal Y means is X equal to Y, and X not equal to Y, X is not equal to Y. So here's how you would give an example in a flowchart. If sales is greater than 50,000, true, give them a bonus. Otherwise, keep going. Any relational operator can be used in a decision. For example, if balance equals 0, or if payment doesn't equal balance. It's possible to have a block, which is the statements, inside another block, which could have another if, like in a function or an inner block. Okay. We can also have if-else statements. This is a dual alternative decision structure. Two possible paths of execution. One is taken if the condition is true, and the other if the condition is false. So, if condition is true, do these statements, and if not, otherwise, do these statements. We must indent them appropriately, and they must be lined up. Here's how this looks graphically. If temperature is less than 40, we say, nice weather. If it's greater than 40, we say, display a little cold, isn't it? And then we continue on. So, if conditions break out like this. If this condition is true, we're going to do the statement block inside here. If the condition is false, we're going to do the statement block inside of here. Similarly, if the condition is false, we'll do the statement inside of here. Control afterwards, in both cases, follows afterwards. So, when we want to compare strings, they're lexicographically compared. And they're case sensitive. What this means is we can compare with greater than, less than, greater than equal, or equal, and so on, and not equal. And they're compared character by character based on the ASCII values. If one word is shorter than the other, the longer word wins. So if we have short word and short words, short word would win. And here's the example. Mary, M and M equal, A and A equal, R and R equal, but Y and K are not equal, and Mark would come first. We can also have nested structures, and also an LF structure can be nested inside another decision structure. A common example. Determine if someone qualifies for a loan. They must meet 2 conditions. Must earn at least 30 grand a year and must have been employed for 2 years. Check the first condition if it's true, and if it's true, check the second condition. So here would be our statement. We'd have an if greater than 30,000 saying is false, saying you must make more than 30. If true, and then you check years on the job. Code-wise, this could be ugly though. When you use indented stuff, you have to use proper indenting, and you could get very deep. So an alternative is to use the if-elif else statement. Elif is else if. And it makes a logic of nested decisions simpler to write. Okay, so here we go. If condition 1 is true, statement elif, meaning else if condition 2 is true, statement else if condition 3, statement else if anything else. Okay. You have to, of course, use the alignment. You have to align the if and the elif and indent appropriately. And you don't need elif. You could use nested ifs, but it's going to get a lot uglier. Look at this case. This would be very ugly when it was nested. Okay, so now we've got all these things. We've got logical operators. We can create complex Boolean expressions this way. So we have and, or, and not. And says, if this is true and this is true, the whole thing is true. Or says, if either one of these things is true, it's true. Not says, if this is not true, it's true. Okay, so here's some truth tables. And is only true in the case where you got true and true. Every other case is false. Or is only false in the case where you have double falses. Now, there's this thing called short-circuit evaluation. It decides the value of a compound Boolean expression after evaluating only one subexpression. So if you say x is greater than 5 and x is less than 10, and x is greater than 5 is false, the whole thing bombs out because it doesn't need to check the rest. Similarly for or, the minute it can tell one of them is true, it stops looking at the rest. Not simply flips it. It says if not x, if not true, and then go through. Okay. You can check numeric ranges by saying, for example, if x is greater than or equal to 10 and x is less than or equal to 20, to determine whether a numeric range is outside of a range of values, you say x is less than 10 or x is greater than 20. You can also have Boolean variables, which have a value of true or false. You can use them to store the results of a Boolean check. You can say, my bool equals x greater than 5, and then my bool will be set to true or false. So, we've discovered decision structures, single, dual, nested, and elif, relational operators and logic operators, string comparison, and Boolean variables. Next, we'll go on to take examples of these.